Mostly what I wanted to do was just kind of summarize what I saw as the questions that were coming out of this particular session. And then we will be following up with another session where we concentrate a little bit more on indirect detection and theory. And some of my questions actually will naturally lead into the next session. But let me first show this plot here, which both Bruno and Peter had shown in their talks. This is kind of showing where we are now with the direct detection searches. And you can see that we have excluded quite a bit of phase space. We have some complications going on with these experiments that are seeing smaller, larger excesses of events. And then David had just shown us some results from the LHC and interpretations that we can make. I grabbed a couple of slides from his talk of the interpretations that we can make if we try to compare these to the direct detection searches. And you can see results from CMS where they're looking quite complementary. And I know that Atlas also has lines that I think the most recent official ones from Atlas kind of are up in sort of this region as well, maybe not quite as strong as CMS if I recall correctly from the reports you have, and Dave is nodding yes. And so this is actually really a great situation to be in. And then if you're looking at Higgs portal dark matter, you can again see that the LHC is providing us something that is compatible. And so this is sort of where we are now. So here are what I see some of the questions and issues are. And some of these questions and issues I'm putting up to be a little bit provocative. Some of them people will have answers to or think they have answers to and are areas of active research. The first question / problem / issue would be a long-standing problem. Dama Libra sees a signal and nobody else seems to be able to reproduce this. And so the question is, can we ignore this? It seems to be a convenient thing if we could just put it to rest and ignore it, and most people, it seems, believes that this is a background. But let me be a little provocative. What if it actually is a real signal? How is it that we could possibly explain this in Dama Libra without seeing it in any other of the target materials? It's actually a pretty hard theoretical question to ask. The second thing that I see is that we are seeing excess events not only from Dama and Libra, but Cogent has shown excess events. The CREST collaboration, which we didn't actually see their analysis put up here, but they did also do an analysis where they tried to model their backgrounds and predict their backgrounds and saw a large excess above it. They're actually in the process of rerunning their experiment now with lower radioactivity materials and with a much better, trying to control their backgrounds better to see what happens with that. And then, of course, oh, this actually shouldn't have said super CDMS. This should have said CDMS too. That was a typo on my part. And so the question is are these signals statistical fluctuations from backgrounds that are either known or unknown, or are we actually at the edge of the discovery? I think in the case of super CDMS and Cogent, CDMS2 and Cogent, we have to be a little careful because these are not 5 sigma sorts of discoveries, right? These are evidence or maybe even just hints that there may be something there. And the thing that all of this, that's really perplexing about all of this, is that except for in the cases of Cogent and CDMS, all of these signals are pointing to different regions of phase space if we take the spin-independent interpretation of these results. And so they're not overlapping. And more troubling, perhaps even, is that Xenon 100 excludes these regions of interest in the above cases. But you can ask yourself, is there room in theory to accommodate all these observations? And the answer might be yes. But the issue, of course, that will come up is that you can suppress a signal maybe in one medium for a while, but you can't do it forever, right? I mean, eventually, Xenon 100, if these events at low energy or Lux or someone in the future should also be seeing events as well. And so we can ask ourselves, is it scintillation efficiency, or is it the galactic halo model that can save us? And we'll hear some in the next session about galactic halo models. Another question issue is that the LHC has not seen a dark matter signal. And the question is as the LHC goes forward and they produce more data, and if they continue to not see a signal, what does that tell us? Does it help us? the results that come from the LHC are a bit model dependent, and perhaps, I'm not sure, Michael, if you will address some of this in your talk in the next session. No, you won't. But there is some model dependency. So we like to throw up the direct detection searches, and we like to throw the LHC results on top of it. And we probably would love to throw the indirect detection results on it too. If we could all put it on one plot, it'd be great. But the problem is that when we do that, or one of the issues is that we have to be really careful about thinking about what we're understanding. Notice when David was putting up his plots, he was saying Higgs portal dark matter. That's one specific thing. These direct detection searches, one of the strengths of them is that they don't necessarily need to have a model in order to see something or to produce these plots of exclusion. They just need a particle to come in and interact in the detector. And they will see some events. And so I think it's great that we have this complementarity, but we have to keep in mind that when we're looking at some of these plots, sometimes we're comparing apples and oranges, and make sure that we understand what we're seeing. And then the final point that I thought was brought up in this session, and Peter had touched base on essentially, is that ultimately when it comes to these direct detection searches, it may be that we're limited by the neutrino background. And so I think this is a great plot. I know it's going to be in the white paper from the SNOMAS output, but where is it that we want to be with all these experiments? And I think the answer is with direct detection, we want to be up as close to this neutrino floor as we possibly can get. And it seems that the next generation, the G2 experiments, will be able to get us there. And so that's my summary of what I thought went on during this session, some of the questions and issues that were brought up for discussion. And hopefully we can carry some of the discussion and some of these questions into the coffee break. Thank you.